Hello everyone, welcome back to the channel. In our last video, we have covered the topics of tuples, sets, and dictionaries. And this is going to be the second last lecture. The last lecture is going to be about recursions. Alright, so on lecture, our topic is basically about functions. In last lecture at end, I gave you a brief about this lecture. That what are functions? Functions are basically reusable block of codes. A block of code that we can use again and again based on the scenario and based on our needs. This is what a reusable block of code is like it is functions. Okay, so in this lecture we are going to be learning about functions in depth, and the last lecture is going to be about recursions, and then you can say that you have like learned all the basics of Python. So yeah, it is a little theory part as we first learn the theory and then we go to the practical part. So the theory is that what is function? First we need to know what it is. A named block of code. A named block of code, as I told, and that performs a single specific task callable from anywhere in your program. Callable. Like you call function. In last lecture I also told you that you call the function again and again. You have to call the function to solve a specific problem. You can call it from anywhere in your code. Okay. And why do we use them? Follow the try principle. What is try principle? Don't repeat yourself with the try principle. So so that you don't have to write the thing again and again. Like you are writing a very long code and one specific task has to be performed again and again. Rather than writing it again and again in all the parts that you have to use it, you can just write a function and then call that function in the specific parts wherever you want it to be used. This is how you're calling that function in that specific place to come and solve it by the principle, whatever principle you have set there. This makes your code really easier to write also and read and also to maintain. As the shorter the code will be, the more readable it will be. If you by mistake do any like error and all, it is easier for you to find out the error. Built from def keyword. There is a keyword def. You use this for every function. Def keyword is used in every function. A function name, optional parameters, and return statement. So how is a whole what do we say function named? Like what is the syntax? First you write the def keyword, you write def def, then the name of function, then the parameters, the conditions or parameters that you want, and then a return statement. That is how you write a whole syntax of a function. Now here is more theory part inputs about inputs and outputs. Parameters versus arguments. So parameters are the variable names defining the function signature. So the variable names that you have defined in the function are parameters, and arguments are the actual values passed when calling it. This you'll get a more proper idea when you'll be writing the code. For now, just understand the variable names are parameters and the values are being called after passing are arguments. It's the scope. Variables defined inside a function are local. So whatever variables will be defined inside a scope, inside the function are will be local. They we can't assess it from outside. They can't be assessed from outside, preventing conflict. Whatever variables are defined inside a function are local. This is done so that if we are writing something outside the function, that won't affect what are written inside the function. Okay. And return values. The return statement sends a result back to the caller. This is how it the right one answer is sent back to the caller. Okay. Without it, a function returns none by default. And if there is no answer for after we call the function and we got no answer, then we are going to it is going to be none by default. Because none of it was printed, none of it came out as answer, so it is going to be none by default. So theory beyond basics, some theory across basics, like more than that. So here are some four parameters. And built-in versus custom advanced concepts. So what are the four parameters? Assign predefined values to arguments. Align flexible function calls without always providing every input. Assigning a predefined value to arguments like uh, value that was already defined earlier by you. It allows it. Okay, allowing flexible function calls without always providing input. Built-in versus custom. Use Python's library function like print and lim as model. Then craft your own solution. You can use these for crafting your own solutions like print and length functions. In advanced concept, nested from functions, encapsulation, encapsulate logic, recursion solves repeating problems elegantly, and lambda function offer concise one-liners. So here are some advanced functions after these like basic functions. We have some advanced functions like recursion is there, okay, lambda and all that are more concise and one-liners. So let an example that first write the define greet and then name. Write the function signature with one parameter. You have to write the function name along with the parameter. Then a docstring, document purpose, arguments and return value using triple quotes. You have to write these using triple quotes. Return a value, then return. You have to write return to send a formatted greeting back to the caller. Call it live test with different arguments interactively in the REPL. Okay. This is basically a theory part, so you need not to take a lot of tension if you're not getting these. As when we move to a Word file and we see all these programs and all, it will be really easy for you. You get everything. When we start doing the questions on our file on compiler, then everything will be easy and clear to you all. Build the calculator. These are where the function's logic can be used. Create a function accepting two numbers and an operator. You can use two functions. You can create a function where you'll be using two numbers and on operating between those like plus minus multiply divide something like that and returning the computed result. That is how you can use. And multiple returns, if you want multiple, use tuples to return several values at one. Example, both the sum and difference of two inputs. Like if you want the sum, the input difference at the same time of two inputs, then you can use tuples. And debug, like troubleshoot the problems, okay, indentation mistakes maybe there, and missing return statements and names error scope issues. So when you'll be learning, you'll be working like using everything on your own, like writing the code, then you get to know wherever the problem is coming, wherever you have to debug. Debugging basically means that eliminating the problem that is occurring while running the code. Okay, so there are some real world examples given to us to help us understand better. Here, see temperature conversion. Suppose you are building a system where, like an app or something, a website, where you just put some temperature and it is converting the temperature into from Celsius to Fahrenheit or something like that. A clear one line function, a reusable block of code that can be used across any climate app. Okay. Data cleanup. Strip white spaces and lowercase strings for consistent file processing pipelines. Stepwise refinement: break a large program into small, testable subtasks, each handled by its own function. So when you make all these functions and all like half of thing, like you just break them down to small blocks that will make it easy. Like you'll be able to see everything stepwise. Temperature conversion, data cleanup, see like this. And like you want to remove all the white space and lowercase and get everything in lowercase like this. Then you get this output, it's like this. In stepwise refinement, like you got lot of information here. Then in this information, let's suppose this is about name, this is about age, this is about city. So it is going to just separate everything, like name here and age here, city here, and then it is going to keep everything separately. Here are some practice questions that you can practice at the end of this lecture, that is refactor, analyze, and design. Okay, and some quiz and assignment thing is here. So now moving to our Word file. Functions in Python. What are the learning objectives? By the end of this lecture, you all will be able to understand what functions are and why they are used. Create and call user defined functions. Alright. Differentiate between built-in and user defined functions. You know that what are built-in functions and user defined functions. And use function parameters and arguments. Okay, understand return values, explore variable scope like local and global, and apply functions to solve real world problems. So here is like a little theory part for you. Introduction to functions. What is function? First thing that comes in every lecture is what is this, what is that. So what is function? A function is a reusable block of code designed to perform a specific task. Instead of writing the same code multiple times, you can just write it once inside a function and call it whenever you need. Okay, here's an example. You wrote welcome to Python again and again. But when you use function, you just write def means define welcome. This is the name of function that you're writing, and print welcome to Python. It will print welcome, welcome, welcome. Let us try this thing. First we write def, then welcome, print welcome. You need to put in color also here. Like this only came once you called the function. I didn't call the function yet, that's why it didn't print. Next slide is why do we use functions? Advantages: it reduces code repetition. You do not need to like repeat the code again and again. Oh, here it is calling the function. Wait, I didn't call it. That's why it didn't go. I'm sorry for that. Welcome. Now, whenever I write welcome over here, it is going to call this function only that it is going to print. Now I wrote welcome, it wrote welcome to Python because I called this function. This is the name of function. I called it over here. Okay. So if I wanted to write three times, I'll write welcome three times instead of writing all this thing. Okay. So here is a real life analogy. Like think of a washing machine. Pressing the start button, calling the function. Like let's suppose that whenever you're having a washing machine, the pressing the start button will mean to you like you're calling the function. It runs a series of predefined steps like washing, rinsing, and spinning without you writing those steps every time. Right when like you are having a fully automatic washing machine, whenever you press the start button, it is automatically going to do like washing, rinsing, and drying, spinning, everything. It is going to do that thing. You don't need to specify every time that do this, do that. All those things are predefined. Similarly, in function, you wrote all those things once, and whenever you call it, it is going to run all those things whatever you have mentioned earlier. Okay. Sorry. So here are some types of functions that we need to know. Some examples are given here. Some built-in functions that are already available in Python that are print, input, length, type, sum, max, min, and range. Okay. And what are user-defined functions like def greet? I wrote greet over here, no? It is a user-defined thing. It was not mentioned earlier. Python doesn't know its meaning yet, right? But I named it. I named it from my own mind. Like I want to name it greet. Okay. So there is like syntax. What is the syntax first? You write def, then you write function name, colon, then you write the statements, then function name for calling it again. Whenever you want it to run the same thing that you have mentioned in the function, you just call it by its name. The components are like def, the keyword to define a function. Whenever you write it, like you are writing a function, you mentioned everything, like all the statements. But if you have not written name, like this keyword def before the function name, so it is not a function. This def keyword is how the Python compiler identifies that this specific thing is a function. Okay, and parentheses for parameters. You need to specify parentheses after the function name. It is necessary. And for beginning the function body, you need to put this colon. Only then we're going to, like, it is going to indentation function code block. Indentation is there, here indentation is there, that thing. And then function call executes function. You need to call the function for execution. But our parameters and arguments. So here parameter, a variable defined in the function. A variable that is defined in the function is parameter, and argument are the values passed by it. I told you in the PPT only, parameters are the variables, okay, that have been defined in the function, and whatever value will be passed by through it while calling it are arguments. For example, this thing def greet name, print hello command name, print greet. Here, like you wrote this greet thing, and then you wrote Rahul over here, so it is going to print hello Rahul. Her name is parameter and Rahul is an argument. You want me to write this one? Def greet, then name, then print hello name. Now I want to greet someone whose name is Rahul. Okay, and hello Rahul. Okay, I called this function. Its name is greet. I called it, and I wrote the name that I wanted to be run for Rahul. So hello and the name Rahul. So here the name is parameter and Rahul is an argument. Some types of arguments are there that are like positional arguments, keyword arguments, fault arguments, the return state, like only this much. Three types of arguments are there. First is positional argument. So here you can see that def add. You have used the function add over here, and you have just written that what has to be done with the variable, like whatever value you got from A and B. And whenever you call the function, it is going to put that thing into add. See, there in earlier things you have to like put user input and everything will be shown in the output that you are putting the values. Here you can only write add. You call the function and you write this whatever value you want to be written. So positional argument is like an input value that an input value passed to a function that will be entirely based on its order or position in the function call. Like it will be all based on the order and the positioning of the function call. Here is the keyword argument. Here is an age. Okay. Mm, here, student, you mentioned the age 20 and name around. These are keywords. The fourth arguments, like the first you wrote this keyword for defining the a function, then you wrote greet the name equal to student. Okay, and then you want that student hello, and then whatever the name of student will be there, you want it to be written here. So you just called the function greet and wrote greet Priya. Let us just, I hope you understand it's working. Let us just write this in our compiler once. Def add comma b, add a comma b, colon, then print a plus b. Now I wanted to add like 89 and 4, and I called the function add, and in add a and b I wrote their values and I called it. So what it is going to do is add a plus b. 93 is the answer, like that. Okay, and the other one was the keyword. Def student name comma age. Bring the name and age, and you call the name student. Like here the thing is that in this the value of A will be 10, value of B will be 20, because they are positioned like first is A, then it is the value of A only. But here they will be defined, the values will be defined based on the keyword. Like 20, you mentioned that age is 20. See, so but age here is written later. First name is written, but as you specified it here, it is going to print like this only. First name will come, age will come. No matter you have written it first or second. Name comma age. Name comma age. Okay, now I called this thing okay student, and I wrote age equal to 20, and I wrote name equal to wait first C first name printed and then age. But here I wrote age first and name later. That thing doesn't matter over here. And here are some default arguments. See, here you wrote nothing over here. Let's suppose you are not having any value for the name part, then what will it do? It will simply print this thing student that you have mentioned in the first line only. But when you have specified the name of the student, it is going to print that thing then. Okay, this is what it meant. Now, return statement. The return statement will send a value back to the caller. It is sending a value back to the caller. Example is given like you have defined a function, its name is char, and you are taking number values in it, and you want to return like number multiplied by number. Okay, and the result square 5. Print result. Print is displaying a value and return is sending a value for further use. It is sending a value for further use. Then return. Okay. Then result equal to square 5. Then you want to print the result of return 25. Print is for printing the result here, but return is for like return will keep that thing to itself. It is going to keep that thing in the memory for further uses. Let's suppose I don't write this thing. If I run it, it kept the thing to itself. Okay. Now if I write the number. Let's suppose I write number 9 in here. Oh, sorry, it is returned now, so it's not going to print. I need to write print over here. Then it will be the same thing that we have been doing in the previous things, but the thing that we just did was like return thing. Return thing is just keeping everything updated. It sends value for further users. Here is like a variable scope. This one on all. This one local variable, global variable. We'll do this only till this lecture and then the recursive functions. This is like a quite vast thing. This thing we'll be covering in the next part. Local variables accessible only inside the function. As when we were learning about the like syntax and all of the function, we learned that local functions, local variables are there. Like whatever variables you would have mentioned inside the function only they could be called or something. Okay, that won't affect anything that is from outside it. Like if some variable is outside the function, it won't really count that thing. Okay, local is like inside the function and it can be assessed inside the function only, and outside it is having no use. It is having, it can't be calculated, it can't be assessed. Okay, so here is like a demo thing. The variable, the name of function is demo, and you took x10, then print x. Now it is only yes, it can only assess the variable 10. It can't take anything else, right? Because it is mentioned inside. This is the starting of, after colon is the starting of function, so it is mentioned inside. Global is like global can't be just assessed inside that inside of a function. It can be assessed from outside also. That is why it is known as global. And the local one is like inside the function, so it is local to us. Global can be accessed from anywhere from throughout the program. Okay, so your x50 is written def demo, then print x. Then if you call demo, then it can be, see it is mentioned before this, before our starting of our function, but still it can be assessed. So let us just try this one, okay? On the compile. Def demo. Static stick x equal to 10. I want 10 x. Yeah, 250. And write this thing. Then I need to call the function. I'm calling demo. It will print what? 50? Yeah. The thing that I did was I didn't call it, that's why I didn't print. In if it is mentioned over here, like x equal to 10, it will print 10 only. Okay, so this was like the two type of variables. This was the difference between them. Local can be accessed from inside the function only, and the global can only be accessed from outside the function. Okay, so this was it, and the next lecture is going to be related to recursion. Okay, so this part we'll do at end, or like giving an idea. First, let us see the summary. Okay, function helps to organize code, and we can reuse the code. We only need to call the function, right? Improves readability, errors will be reduced, and we can build large applications efficiently. So here are some examples. Simple function. Okay. So lots of examples are given. This is also here for us to, like seven examples are there, and 10 programs are here for us to try. First is this welcome thing only, we did it earlier only. So I don't think I need to do this one. And this greet name thing, we did this also. Still, let us try it again. To, I'm not writing it all because I think know it all. Print hello Rahul, hello Priya. Yeah, like this. Okay. Second is this addition thing. That's add A, comma B. Okay. Now you want to print some, comma, add, oh sorry, A plus B. Now you call the function add. You're putting the values in it. Let be 90 and 34 and 24. See, some is printed like that, and A plus B like that here in front of it. So function returning a value. You wrote this multiply function when you mention two variables A and B in that, and then you return a star B, like A multiply B. And then you wrote like result should be equal to multiply, then 6 and 7 is written here. So as a result it is going to multiply 6 and 7. Okay, you didn't write the function here like star thing. It is written here. It is for storing this info, but this one is for printing the thing. Result equal to multiply 2 and 3. Six. 2 threes are 6. It is printed like that. So here is like for finding the square thing. You did it right, but you did it already. Just check even or odd. For checking even or odd function is there. First, you define the function name as even underscore odd and number, and then you put the condition that if number is the modulus. So here, like modulus is the like it's a remainder. It basically means that if number will be divided and its remainder left will be equal to 0, then print even. Any number will be that any number, any even number will be divisible by 2 and its modulo, like its remainder is going to be 0, right? This is how we define it. Or else we print return odd. We don't write print here, we odd or print return. Then we write the condition. Here we take number. Okay, and then we write this 2 double equal to 0. Then return. What do we return? Even, right? Even. I don't think we need to type it. Even. Else. Return. Now I want to print let's suppose I call the function even and for the number 9, but I didn't write print over here, so how will it print that thing? Here the thing was written on that return. If I would have written here print, then I didn't need to write print over here, but I didn't write print here, I just return odd number or 0. It's even, right? Even. Here is another program, largest number, for finding the largest number. Here you have named the function as largest, and if a is greater than b, then return a, and then you want to return b. Like first the largest number will be written, and then the other one. Largest. Here then if a greater than b, return a. Instead of normal, it's supposed to be a comma b. 6 c, 6 is greater. Here it was like if a is greater than b, then return a. Otherwise, you have to return b only. So here b was greater, so it returned b. Okay, so it's factorial. How to find factorial using a function. So first define factorial n. Starting point you wrote 1. For I in a range 1 and comma n+1. Factorial multiply equal to I, return fact. Print factorial of 5. And find for I in range 1, comma n+1. For I in range 1, comma n+1, then I write the column and fact star equal to I. Then I return the fact, print factorial 5. Return print factorial of 7. This is the factorial of 7. And if I don't want 7, I want 99. Factorial of 99 is going to be this much long. If about 9, then if we find the factorial of 9, it is going to be this much. Okay. Now moving on to this ninth program, we are defining welcome. Function name is welcome. Name is given student. Print welcome name. If you only write welcome like this, it is going to by default print student over there. Welcome student. Okay. And if you write specify some name over there. When after calling the function, then it is going to print that name after writing the welcome thing. We did this one, and this is calculator using functions. So we have written lots of things over here. See, here we have defined 5 6 functions that add, subtract, multiply, divide. 4. Okay, basic operators. 4. So you have defined all of them. That if add is there, return a plus b. If subtract is there, return a minus b. If multiply is there, return a star b. But for divide, one complication is there, that the denominator should not be equal to 0. We all know that thing, for that is like a necessity for division, that the number that is having 0 in its denominator, that is not defined. So for that we need to mention a condition over here, that if the b here is going to be the denominator, if b is not equal to this exclamation and equal to together means not equal to 0, then return a slash b, a divided by b. And if not, then here after this alignment should be this, return division by 0 is not allowed. Okay, that is move on to the real world examples. Yeah, we'll be mentioning the condition. So here we tried all of these like add, subtract, multiply and divide with two numbers, that is 7 comma 4. Alright, so here we have done our 10 program practices over here, and now we are moving on to the real world examples. Here 10 examples are mentioned that in reality where all of these things are used. Then I'll just tell you about some questions that you can practice on your own for making yourself like better. So here for student grade calculator, it's a student grade calculator given over here. Here you just wrote the function name, grade and marks you mentioned. If marks are greater than or equal to 90, return A. LF ladder is used here. Greater than or equal to 75, return B. LF. Just how we were using in the conditional statements of LF ladder. Just like that, we are just writing here. It is inside a function, so we are just writing return instead of print. And whenever we want to print, we will just say print and grade and whatever marks we want here after calling it. Okay. Online shopping discount. So here you have written define calculate discount, and inside you are going to write the amount. If amount is going to be greater than or equal to 5,000, then you want to return amount in amount multiplied by 0.10 means 10%. You are going to give them some discount, or else you are going to return 0. You would return 0. Okay, let us just write this one. See, so 7,000 is made into 700 after the discount is given. Alright. What if it is less than that? Let's put it 900 less than 5,000. So discount that will be given is 0. ATM balance check. So this is how you can build a system for checking the balance. You wrote the name of the function as check balance, and then inside balance that return balance. It will just return the balance to you. Check balance for 15,000, and it will tell you. I'll just write it there. 15,000. Area of a circle. How you can find the area of a circle? For that, need to return 3.14 into r square. So r into r, radius into radius. Print the area of 7. Yes, there is pi r square, right? So pi value is written here 3.14, then a square like r square, radius square. This is the area. Okay. Password verification. For that, you want the password's length should be more than or equal to 8. Okay, valid password type. This is how you can check if the password is valid or not. It is used in various systems when you are setting your passwords. True. It all if it is valid or not. True. So temperature control is again here. And then next is salary calculator. You can see that like you have named that function as Celsius underscore to Fahrenheit inside your written C is like mentioned depicted to the name like temperature that you have given earlier in Celsius. So for how to convert Celsius to Fahrenheit, that is multiplying it by 9 into 9 upon 5 and that adding that adding that value to with plus 32. Okay, and then printing that same 77 for 25. If you convert 25 degrees into Fahrenheit, and that is going to be 77. Another is salary calculator. So here like net salary and basic income bonus is given over here. So return basic plus bonus. So this is how you can get the net salary. It will just add your basic salary with the bonus thing, that whatever bonus you're getting, how much you're getting, and it will add it. It will show you that how much bonus you get. Some practice questions are given over here that you can try. Half of them we would have tried earlier only in this lecture only. So okay, so even if you want to try them, you can try like write a function to print your name, or write a function to add two numbers, write a function to find square, or find printing a welcome message, write a function to find largest of two numbers, whether a number is even or odd, calculate the factorial. We did this one. We did all of these that we just read now. And write a function to calculate the area of a rectangle. Sorry. Now write a function to check whether a number is prime. Write a function to reverse its prime. Write a function to calculate the average of a list of numbers. Write a menu driven calculator using separate functions for each operation. So here is a little quiz for you all to memorize everything that we have just done. Which keyword is used to define a function? Keyword. It's def, right? Uh, and which statement sends a value back from a function? Return. C. Which of the following is a built-in function? Which of these are built-in function? C. Yeah, welcome we give on our own thing. Add also we give on our own. Greet also we give on our. But length was predefined in the lecture. In the top we studied in the first, second, or third slide, I guess. In there, built-in functions were given, and then user functions were given, that variables that we give. And over there, length was there. So see, this is built-in function. A variable created inside a function is called local. We discussed it a lot. And a function calls uses a function call uses keyword. Which function call uses keyword argument? So in all of this, which one is function is calling keyword arguments? See here, it is like mentioning by its keyword name. It is giving the value using its keyword name. So this is one that is using keyword arguments. Okay. So here are some assignment thing for you. Or write a function to calculate the sum difference product or and quotient of two numbers, and write a function to check whether a number is even or odd. Write a function to calculate the factorial of a number. Write a function to check whether a number is prime, largest of 3. Write a function to accept a student's mark and returning to the corresponding grade. This we did, like in the top it was given. Write a function to calculate the area and perimeter of a rectangle. Write a function to reverse a string without using built-in reverse method. Create a simple calculator using separate functions as add, subtract, multiplication, division. We did this one. And write a function that stores student information in a dictionary and uses function to add a student display all students, search for student by name of data, students marks. Okay, so key takeaways that we did now is like function help organize and reuse code, and use parameters to accept input and arguments to pass the values. Use return when a function needs to send back a result. Okay, and function makes programs easier to test, debug, and maintain. Okay, absolutely. So breaking a large problem into small function is a fundamental programming practice used in professional software development. So this is all that we did today. Next thing that we'll be doing is about recursion. Recursion is also a type of function only. Helps, it really helps in coding. And here, see, we're going to give introduction for that. A function that calls itself is recursion. See, here is an example given. Mentioned that recursion will be studied more detail in advanced. Yeah, I'm going to take that in next lecture. So here is an example given over here for recursive function. Next lecture is going to be like a whole explanation, detailed explanation about recursion. Basically, what is recursion? It is a technique where function will call itself and its own body to solve a problem by breaking into small little problems. Like it is going to make sub problems of a big problem, and then it is going to solve it. Like there are two things in the syntax of recursion. First is base case and next is recursive case. Okay, base case is like a conditional exit checkpoint that stops the function from repeating forever. Like you don't want to the function to repeat itself forever, right? It needs to stop at some time, so it is for that. And recursive case is the line of code where the function will use itself, like using modified smaller arguments like that. So it might be a little confusing for you right now. Next lecture will be really easy. It is going to cover all of the things, all of the introductory part will be there, programs will be there, examples will be there, real world examples will be there, quiz will be there, and some homework type things will be there. Like you can try those things on your own to make the learning more effective. So I hope that you are getting everything that I'm telling. And this was it for today's lecture. In next lecture, we'll do recursion, and that is going to be our last lecture. Thank you so much for watching the video. That was it for today. Thank you so much for watching.